This video is to demonstrate the use of the redox half reaction method to balance this reduction-oxidation reaction. The first step, which is in a lot of ways the most important, is developing a pair of half reactions. In order to do this, you want to pick your reactants and products in such a way that you have something that's able to be balanced with a little bit more work. So in this case, I have one half reaction here and the other one here. Now, once this thinking step is done, the rest of it is balancing mass and charge for the half reactions, leading up to a recombination step, where we put everything back together, cancel out what we can, and then verify that we have actually completed this reaction. So, the first step, then, is to balance mass, and in this case we're talking about everything that is not an oxygen or hydrogen. So, we need 2 here, because that will balance our chlorines, and we don't have to do anything at all here, so we can just carry that down. The next step is more mass balance, but this time it's balancing oxygens, and we want to balance out the oxygens by adding in water. The assumption is that your redox reaction occurs in an aqueous environment, and therefore there are lots of waters available to mediate this reaction. For this half reaction we have a total of 8 oxygens, and so we will need to add 8 waters as product to balance out the 8 oxygens that are reacting. This next step requires us to balance the mass of hydrogens. By adding in the 8 waters, we have added 16 hydrogens, and that means that to balance that out, we will need to add H+. And at this point, all of the matter is completely balanced. However, our charge is completely out of whack. And so the only way we can balance our charges by not messing up our mass balance is to use electrons. Electrons have a -1 charge, but are not massive enough to influence that portion of the balance. And so we want both sides of the half reaction to have the same total charge. Here we have 2 things that are neutral, so the product side has a charge of 0. We have 2 negatives and 16 positives, meaning that we have 14 positive charges overall. So we can bring that down to neutral by adding in 14 electrons as a reactant. And so now the mass and charge on this half reaction is balanced. We'll go through the same steps for the other half reaction. We have 4 oxygens on the product side, so I will need to add 4 waters on the reactant side. 4 times 2 gives me 8 hydrogens, so I can add 8 hydrogen ions, H+, on the product side. And now that the matter is all balanced, I only have to respect charge. Here I have +2. I have 8 positive charges versus a single negative charge. So I have +2 versus +7. If I add 5 electrons as products, this will allow both sides to have the same charge. The charge balance step is not about making everything neutral. It is about ensuring that on either side of your individual half reactions, you have the same amount of charge. So once that step is complete, we need to do a little bit of housekeeping, what I like to call the pre-combined step. And so the pre-combined step requires that you observe the number of electrons you have, verifying that one half reaction has electrons as reactant and the other half reaction has electrons as a product. Once you've verified that, meaning you've done all balancing correctly, you have to determine what you're going to multiply each side by so that you can cancel out your electrons. If I multiply this side by 5 and multiply this one by 14, I can guarantee that when it comes time to do the next step, the full recombination, that all of these electrons will completely cancel out. So now we're entering the home stretch because all we have to do is make sure that we achieve proper cancellation. So I'll write out my first half reaction properly multiplied. So 5 times 14 will give me 70 electrons. 5 times 16 will give me 80 hydrogen ions. And 5 times 2 will give me 10 perchlorate. On the product side of the first half reaction, I have 5 there, and 5 times 8 gives me 40 for my water. I'll do the same thing for the second half reaction. 4 times 14 will give me 56 waters. And 14 plus. So now I have to multiply it by 14 on the product side. This gives me 70 electrons. 14 times 8 will give me 112 hydrogens and 14 permanganate. So now that I've completed the recombination step, I have to make sure that I do all of my cancellations correctly. I note that I have 70 electrons and 70 electrons, so these will cancel each other out. I have 80 hydrogens as reactant and 112 as product. This means that all 80 of these will cancel, and that will leave me with 32 hydrogens. By the same token, 56 waters as reactants and 40 water molecules as product. All 40 of those will cancel, and this will leave me with 16. So in the final step, all I have left to do is write out everything I have left. And because this is done in an acidic environment, the assumption that we're allowed to make is that this is completely done, and that the water and hydrogen ions that we find here in the balanced reaction that we do not find in the original are the result of being in an environment where you have an excess of water molecules and an excess of hydrogen ions.